Okay, Psych class, welcome to part 1 of Unit 4A on memory. Let's begin with a definition of memory. Memory is the persistence of learning over time through the encoding, storage, and retrieval of information. We'll explain what encoding, storage, and retrieval are at the end of this video, but the key here is the persistence of learning over time. It does us no good, to employ any of the methods or theories in Unit 3A on learning if the stuff that we learn doesn't stick around in our brains to use at a later point in time. And so that's the connection between what you've learned before and this new stuff on memory. Okay, so let's talk about the 3 stages of memory. Now notice that I have the word stages in quotes, meaning I don't want you to think that there are actual places in your brain that are called these things. But this is kind of what's known as the information processing model of memory. And the analogy is that our brain is like a computer in the stages that a piece of information goes through to become a memory. So the first thing here is that our experiences, what's going on around us, are just for a moment recorded as sensory memory. And that analogy would be, your computer just doesn't absorb information from its surroundings, just like we don't do that. We have to pay attention to put the information in, and that would be no different than, like typing the information in your computer. Right, so the information is processed into what's known as our short-term or working memory, and that's just where items are held briefly to either be used or be worked at storing. And so think on your computer as you're working on something, that would be analogous to your short-term memory in your brain. And then if you want to store something to use at a later point in time, we move it to long-term memory. So you can think of that as, like storing it on the hard drive of your computer. You don't just, like work on things on your desktop and then turn your computer off without storing it. And so memories are no different. So again, there's no actual place in the brain that's called sensory, short-term, long-term, but the analogy is helpful for understanding how memory works. Okay. Not all memories get to long-term memory the same way. We have 2 different ways. We can automatically process a ton of stuff on a day-to-day basis. Unfortunately, the stuff that we tend to really need to want to know is effortful processing. And so you can see the chart on the right. Automatic processing, where you ate dinner yesterday. Were you at a restaurant, a friend's house? Were you at your own home? We don't, you can answer those questions if somebody asks them of you with pretty little effort because that was automatically processed. But effortful processing, like learning this new unit, that actually takes some work. Unfortunately, the things that we seem to really need in life tend to require effortful processing. Okay, so some examples of effortful processing. One of the things that's important to remember is what's known as the spacing effect. We actually remember things better if we study or practice them over a period of time. And this would explain why, teachers always tell students that cramming is not effective, but now you know the psychological reasons why. And that the more that you practice putting things into long-term memory, bringing them back out and using them in short-term memory, and then restoring them in long-term memory, if you can space those processes out, you tend to remember the information better over the long run. A way to do that would be known as the testing effect, right? Repeated quizzing of previously studied material is what's going to help you do that. So constantly quizzing yourself over new information, versus just staring at your notes and being like, oh yeah, I recognize that as stuff that we've learned. Actually using the information is going to help really store it in long-term memory. Okay, one other thing to keep in mind concerning the storage of information would be to talk about the serial position effect. When we are forced to rehearse a long list of things in short-term memory, we tend to have better luck at remembering the things at the very beginning and the very end of the list best. And after some time, we tend to remember the items at the beginning even better than we recall the items at the end. And so keep that in mind when you're trying to learn new information. Don't just, your stack of note cards, don't just go over them in the same order, or otherwise you'll just remember things at the very beginning and end of the pile. Additionally, does this not explain why cramming doesn't work? Yeah, right? That if you cram like for 2 hours at a time, you're going to remember the stuff that you did at the very beginning of your 2-hour session and the very end of your 2-hour session, and everything in the middle is going to be forgotten. And so keep that in mind, right? Spacing effect. Short, little, concise. Quiz yourself over a long period of time because of serial position effect. Okay. This chart is great here for you visual learners. Some things that you'll want to write down on the chart. I don't know if you can see that they're in bold there, right? Concerning our memories, we have 2 different types of long-term memories. Explicit, those are the ones that require conscious recall, and implicit, they're without conscious recall. And then some examples are there at the very bottom of the chart, right? Explicit memories are like facts and events. And as you well know, these are the things that require effortful processing, right? You can see that they're actually processed by a different part of the brain. The hippocampus is in charge of helping us store facts and events, whereas our skills and the things that we've been conditioned to do are actually processed by other brain areas, such as the cerebellum. And so this could explain why even people that maybe suffer from specific brain injuries and have amnesia may not remember specific people or events, but could still be taught new skills. And that just has to do with the different types of memories and the places in the brain where those memories are processed. Okay, so let's talk about how something becomes a memory. We talked about the stages, or like the places where they go, right? First sensory, then short-term, then long-term. But let's talk about how we move things from sensory to short-term to long-term. Okay, so these are really nice, short, concise definitions if you're looking for that. Here it is, right? Encoding would be getting the information in. Storage would be retaining that information, and retrieval is getting the information back out. Okay, so look, the key to encoding information or moving it into short-term memory from sensory memory is to apply meaning to it. Things that have meaning tend to be more likely to remember than things that don't have meaning to you. And so yes, I know that there are classes in school that you just don't like, but the key is to find something about them that's meaningful to you, and linking that information to something personally meaningful will make it easier to remember. Okay, concerning storage, something to keep in mind. Short-term memory is limited in its ability to store anything, right? It's short-term. Things last seconds in short-term memory and then they're gone. The key, thanks George Miller, is coming up with the magical number 7 plus or minus 2. So know that your short-term memory really only has a capacity for 5 to 9 things at any one time. And after that, you either have to rehearse it enough to store it into long-term memory, or it's going to be forgotten. Okay, long-term memory doesn't seem to have any limit, and things that you learn can endure for a lifetime. The key is obviously practicing that information to keep it fresh in one's mind, and again, as mentioned before, keeping it meaningful. Okay, so how does the brain actually store things in memory? Okay, your brain's not like a library, and things aren't in these precise, neat little files or like on your computer. Various neurons are assigned the task of remembering information. And so some key things about the brain that's important to know concerning memory. The first is remember those synapses. We kind of talked about this. Remember our rats in their enriched environments as children had better synaptic connections, right? So you know this. The more experience you have with something, the stronger the neural pathway is, the easier it is to remember that piece of information. Secondly, emotion tends to trigger memories. We know that things that are of high emotion tend to trigger hormone release in our body. Hormones tend to up the amount of glucose in the body, and glucose, if you remember from biology class, is what cells eat for energy. And so there may have been moments, either extremely happy moments or extremely sad moments in your life, that it's almost as if they're recorded like with a video camera, or that's why we call them flashbulb memories, like vividly clear memories of something that's emotionally significant. An example for some older people is that they tend to remember exactly where they were on September 11th, 2001, to the specific detail. You were younger then, but I was older. I can remember like what I was wearing, what I ate that day, some pretty specific information regarding that as a result of it being so emotionally charged. Okay, so we've put the information in encoding, we've worked at keeping it there, storage. Now let's talk about getting the information back out. That's retrieval, okay? And so evidence that something has been remembered. You can either recall it, which is actually the hardest of the three things to do. And so that's like fill in the blank tests or an essay test. Or you can at least recognize it, like on a multiple choice test, right? That's usually the quickest one. Like, you don't necessarily have to straight up remember something. You just have to identify it as something that you've learned in the past. And also know that relearning an item may be easier than it was the first time as a result of that neural pathway kind of already being there. And so, this is one of my pet peeves whenever anybody tells you that they're just so much better at remembering faces than they are names. No kidding, everyone is, right? Now you can tell them that. You idiot, everybody's better at remembering faces than names. Well, maybe don't call them an idiot because, you don't want to lose your friends and all that good stuff. But politely tell these people, right, that remembering a face just requires you to recognize as, hey, I've seen that guy before. Actually remembering their name is recall, and you now know that that's a much harder task than just recognizing a face. Okay, so how can we make retrieval a little bit easier on all of us, all right? Well, here's some different retrieval cues that can kind of help you. All right, so we know that memories are linked together in the brain in this web of associations. And so if you can use these associations to your advantage, you can use those as retrieval cues. So any stimuli, like events, feelings, or places, can be linked to a specific memory. Think back to what we learned earlier in the video concerning automatic processing. If these random things like what we ate for dinner or what we were wearing yesterday are automatically stored in our brain, then we might as well use that stuff to our advantage in order to remember the stuff we actually need to retrieve. And so the more retrieval cues that you can encode, the better chance you are of finding that path needed to retrieve that memory. Two of the most popular examples are these. Context effects. Returning to the context or the place where you experienced something can prime your memory of it. And they actually did these fun experiments where they had scuba divers learn lists of words both on land and underwater. And then you can see on the chart, look, if you were in a different context, it made it harder to recall. If you were in the same context, it made it easier to recall. Hey, whenever you lose something, what do we always say? Retrace your steps, right? If you walk out of your bedroom and into the kitchen and say to yourself, self, why did I just come into the kitchen? You know what you need to do? Just walk back into your room and walk out again, and chances are you'll remember why it was you had initially moved to the kitchen. So context effects, important to remember. The second one that's important to remember is mood congruent memory, right? We can more easily recall experiences that are consistent with our current mood, good or bad. And so some of the fun studies that have been done on this are that teens actually rate their parents based on their current mood, all right? So mood can also affect what you remember. You're mad at your friend, you tend to remember everything that annoys you about that person, right? Because of mood congruent memory. Okay, so a lot thrown at you. Just bring any questions that you have with you to class. We'll check out these notes and we'll start applying them with some different examples and demos. Thanks for listening.